Okay, this is going to be a problem session for Fibonacci, and we'll just start off with first problem. What is Fibonacci 12? Now, if you're following this, this is where you can hit the pause button, and then you can just come right in, and after you've worked on it yourself, we'll do it. Okay, now the way to solve this is first you write down the Fibonacci's. 1, 2, 3, 5, 8, 13, 21, 34, 55, then above them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11, and we go up to 12. 55 and 34, that's 89. Okay, and this one is going to be, oh boy, 130, 144. That makes sense to me. Let me just check. Yeah, 144. Okay, now. So, F12 equals 144. Because it's the 12th Fibonacci number. Great. First problem. Done. Second problem. What is F? 12 minus 1. Okay. Now, here's where you can hit pause. This is all about notation. Because the minus 1 is big, this is 144 minus 1. That's 143. Okay? The idea is the minus is not coming off the 12, it's coming off the whole Fibonacci number. Okay? Okay. Next problem. Okay. This one says F. 12 minus 1. Okay, now, the idea on this is to see that this 1 is a lot smaller. So this is really, this is where you hit pause, but this is really F11. F11 is 89. Okay. So that's the answer to that one. Okay, great. Just gonna keep rolling. Next one. F. 12 divided by 4. Okay, hit the pause. Okay. Now this is 144 divided by 4. Because this is divided, the entire 12th Fibonacci number is going to get divided by 4. Okay, this is equal to, first I'll divide by 2, that's 72 over 2. And then I'll divide that by again, and that's going to be 36. So that's the answer. Okay. Next problem is F. 12 divided by 4. Now here, this divided by 4 is much smaller. This is really the Fibonacci number of 12 divided by 4. 12 divided by 4, that's 3. This is equal to Fibonacci 3. That's equal to 2. Okay. Okay, great. So, now let's move on to a few more now. What is this number? F. What is F1 plus F3 plus F5 plus F7? That's the sum of these Fibonacci numbers. Pause, then you come back. F1 is equal to 1. F3 is equal to 2. Fifth Fibonacci is equal to 5, and the seventh Fibonacci is equal to 13. Okay, now that's 3. That's plus 18. That's 21. Okay, 21. That's the answer. Okay, let's go to the next problem. Problem says, what is F1 plus 3 plus 5 plus 7. This is a lot like all the problems we've been doing. This is, you have to add these up first. This is equal to F21. Oh boy. Well, that's going to take a little work getting to. We haven't got up to F21 yet, but well, I guess we'll have to work at it. Okay. 13, 14, 15, 16, 17, 18, 19, 20, 21. This is where it helps if they have like a little table with all the numbers ahead of time. We can always add them all up. No problem. But this next one is 233. And after 233 comes 377. After 377 comes 610. And then the 16th Fibonacci number is 987. We still have a ways to go. 987 plus 610. 7, 9, 15, 1597. That's the next one. Okay, 1597 plus 987. 4, carry the 1. 18, carry the 1. 15, carry the 1. 2, 5, 8, 4. Okay, 2, 5, 8, 4 plus 1. 5, 9, 7. 1, carry the 1. 18, carry the 1. It's 11. Carry the 1. That's 4,181. Plus 2, 5, 8, 4. Okay. 5, 6, carry the 1. 7, 6, 6,765. Add 4,181. 6, 4, 1, 9, 10. 10,946. 10,946 is the answer. It takes a little bit of work to get to that. Okay, great. Now, let's go to the next one. Problem is, what is F10 divided by F5? Okay, F10 is 55. F5 is 5. Answer is 11. Okay. Next problem. What is F10 divided by F5? Now here, you just want to divide the 10 by the F5. Okay, so that's F. 10, F5 is 5. So that's the second Fibonacci number. And that's equal to 1. Okay. Here's one. F7. Okay, the seventh Fibonacci number is 13, so this is equal to F13. Now the 13th Fibonacci number is 233. Okay. Now make sure you're using the pause button. Make sure you're doing these. It's not going to help you if you just watch me do these. This is just practice. Okay, now, next one says, describe in words what each of these expressions represents. Now, here we go. 3, F, N, plus 1. In words, this would be, 3 times the nth fibo, then, or I could do this, 1 plus 3 times the nth fibo number. Okay, that's using words. Okay, next one. 3 F N plus 1. This would be 3 times the N plus 1 fibo number. Okay. Next, F 3n plus 1. This would be 1 plus the 3 times n fibo number. One plus 3 times n. Oh no. 1 plus the. I would spell it this way. The 3n. Oops. The 3n fibo number. I guess that's okay. 3n. The 3 times n. Wouldn't want to be 3 times the nth fibo number, so I guess you have to call it the 3nth fibo number. Right? The words are less precise than the actual math, so. Okay, next one. F 3n plus 1. Okay, this will be the 3n plus 1 plus 1 fibo number. The 3n plus 1 fibo number. Okay. Now let's go to the next one. Now this one's going to be a little bit trickier. So, we've got the recursive rule of the Fibonacci's, which says the nth Fibonacci is equal to the sum of the previous 2 Fibonacci numbers. Now, this is only valid. This expression can only be valid for n greater than 3. Possibly also equal to 3 is fine. And the reason is because it involves the expression n minus 2. If you put in 3 there, that's okay. You get 1. If you put in, if you put n equals 2 in this, this is going to say f0. But we don't have anything called f0. The Fibonacci number is only starting at 1, so this is not. This is kind of a nicety. This is the Fibonacci recursive formula. It's really only valid when n is greater than or equal to 3. Okay. So now they're saying, is this equivalent to one of these following? For example, take the statement f n minus 1 minus fn equals fn plus 1, n greater than or equal to 1. I'm sorry, just say n greater than 1 is what it says. N equal to 1, that wouldn't work, that would be 0. Or fn plus 1 minus fn equals fn minus 1. N greater than 1. Okay, now, what they're saying is, they're calling this 1 and this 2. And they're saying, which of these is equivalent to the Fibonacci recursive formula? Is it this number 1 or is it this number 2? And it's a little harder than the other ones. Now, the way to do this, or one way to do this, is to just think about it in terms of the words. What this statement is saying is that the Fibonacci number is equal to the sum of the previous 2. So if you look at the n plus 1, that's the highest number here. Is this equal to the sum of the previous 2? Previous 2 would be n and then minus 1. No, it's not. It's actually equal to the difference of them. This is no way could that be the same. Now, this one down here, f of n plus 1. This is the n plus 1 is the highest. It's called an index. It's the highest number. This is the highest Fibonacci number here. Is this equal to the sum of the previous 2? Well, actually, on this equation,